Hi guys. I am going to go over the first day of your first week review packet. So we're going to take a look at these problems and I'll go over them. If you're confused at any time or have a question, you should pause the video and type your question into the chats box on Gmail or into the comment section on Google Classroom. And thank you, Stephanie, for letting me borrow your paper. I gave you a different one yesterday. So the first question says, an expression is shown below. We know it's an expression because it doesn't have an equal sign. So it's just two values and then we're trying to add them. It says, circle the expressions below that have like denominators that could be used as a next step to add the two fractions. Select the two correct answers. So, okay, that's important. I need two answers. But these are confusing directions, so I'm actually going to read them again because we know that good mathematicians, we need to understand what we're doing before we get started. So let me look again. Circle the expressions below that have like denominators. Okay. So I know that if I want to add fractions, I have to have the same size pieces. That's like denominators. Okay, so it's asking me to circle ones with like denominators that could be used as a next step to add the two fractions and select the two correct answers. Okay, so I'm noticing I don't actually have to add them. I just need to figure out what my next step could be. All right, so let's look at each option. The first is 3/4 plus 1/3. Okay, so 3/4 is equivalent to 9/12. And 1/3 is equivalent to 6/18. So those are the same values, but they don't have the same denominators. So that one can't be it. This one says 9/12 plus 4/12. Okay, well then 9/12 is staying the same. 4/12 and 6/18, I'm not sure about that, but they do have the same denominator. So I'll come back to this one. I could be right. This one is 9/12 plus 6/12. Okay, well, again, 9/12 is staying the same, but 6/12 is not the same as 6/18. So I also know that this one can't be it because those would not be, I couldn't use this as my next step to solve these because I've just totally changed this value. I know 6/12 is the same as 1/2. Exactly. Hopefully you knew that as I asked. Okay, here's 18/24 plus 8/24. Okay, they have the same denominator, so that's good. I'm not sure right away if these two values are equivalent, so this is another one I have to come back to. 3/4 plus 2/9. Okay, well, again, I know that 3/4 and 9/12 are equivalent, but look, these two have two different denominators, so I can cross that off right away because that's not going to really help me add them, even if both things are equivalent. Okay, and lastly, we have 9/18 plus 6/18. So this time the 6/18 is staying the same, so that's good. They have the common denominator, but 9/12 is not the same as 9/18. So this one I can cross off. Okay, that just leaves me with B and D. So I actually think those are my two correct answers. But just to double check, let's make sure that 6/18 is the same as 4/12. So this is a little bit tricky because it's not the way we've usually been finding equivalent fractions. I'm going to say 6/18, what is that equivalent to? So I could do like 12/36, or I could even do 24/72 or something. But those are all getting a lot, having larger and larger denominators, and here I want one that's smaller. So instead I'm going to go ahead and try to find a simpler fraction. So I know that 6 and 18 both share a common factor of 3. So I'm going to divide. 6 divided by 3 is 2. And 18 divided by 3 is 9. Okay, so that gets me my 2/9. And I still don't know if that's the same as 4/12. Let's try another one. Good mathematicians, we don't stop. We know we could find a lot of different equivalent fractions, so I'm just going to test out a couple. Let's see, so 6/18 is 6 and 18 also have a common factor of 6. Huh. So if I divide by 6/6, again, that's a version of 1, then I get 1/3. Okay. Now is 1/3 the same as 4/12? Well, I got to test that out by looking at 4/12, and can I make that equivalent to some number of thirds? Well, all right. I could divide by 4/4. Huh! That means that 4/12 is equivalent to 1/3. 6/18 is also equivalent to 1/3. So that's one of my answers. Now I'm going to do the same thing over here, actually. The 18/24, I can kind of see right away that's going to work with my 9/12, because if I multiply by 2/2, 2 halves, I get 18/24. Great. Now let's see. Knowing that 4/12 is the same as 1/3, let me try that as well. So 1/3, can I make that into 24ths? Let's see. Sure I can. I can multiply by 8/8 and end up with 8/24. So those are my 2 correct answers. See, that was kind of a lot of work. And it didn't actually require me to ever add these 2 fractions. So check your own paper and see if you rushed right into adding them because you didn't really carefully read the directions. And then if not, hopefully you notice that A, C, E, and F wouldn't work. And then the next big step would be to check if B and D did work and if they were correct, and they were. So that's the first problem. For our second problem, an old comparing, a list of fractions to compare. So I remember comparing fractions we did a little while ago, and we had 4 strategies. I'm wondering if you remember them. I'm going to write them down here. We had compare to a benchmark, or a landmark. We had common numerator. We had distance to a landmark. And then we had common denominator. Okay, let's take a look. So right away I see this one is more than a whole. So some of you might be like, oh, so this is a mixed number, so that must be bigger. But wait a minute. 14/3 is also bigger than a whole. Why? Because the numerator is bigger than the denominator. So let's try to figure that out as a mixed number so I can compare them. I shouldn't just be doing this mentally. I want to write this down. So 14/3, let's see, 3/3 is 1 whole. 3/3 is 1 whole. 6/3 is 2 wholes. 9/3 is 3 wholes. 12/3 is 4 wholes. 15/3 would be 5 wholes. We don't have 15/3, we only have 14. So that means it's 4 wholes. That's 12/3 is 4 wholes. And then 2/3 left over. Okay, so that's 12/3 plus 2/3. I know the 12/3 is the 4, and the 2/3 is what's left over, so that's the fractional part. So these ones are actually equal. This one, which strategy can I use here? Well, they both have 7 as their numerator, so we'll use common numerator. Which one is bigger? Well, the 13ths are bigger pieces. So the bigger the denominator, the smaller the piece. They have the same size, same number of pieces, but the 13ths are bigger, so 7/13 is bigger. 8/9 or 7/8. I wonder which one you used for this one. Hopefully you notice something about both of these are 1 piece away from a whole. But this one is 1/9 away from a whole, and this one is 1/8 away from a whole. ninths are smaller than eighths. So 8/9 is actually bigger. It's a little bit closer to being a whole. This one, we have, if we notice, both fractions are 20/3. So we could use our common denominator. Also, you might notice that 17/23 is bigger than a half, and 4/23 is smaller than a half. So we could use either of those strategies, common denominator or compare to a landmark. And 17/23 is bigger. Okay, now we have 5/13 and 9/16. Well, they don't have the same numerator, they don't have the same denominator. So I can't use either of those ones right away. They're not both just one piece away from a whole, like we had in C. So let me try a landmark. So 13ths don't have an easy half. It would be 6.5 13ths would be the half. Or we could think that if I have on my number line 0 and 1 whole, 6/13 would be kind of the smaller piece, and 7/13 would be the slightly bigger piece. Either way, 5/13 is less than a half. In 16ths, 1/2 is equal to 8/16. So 9/16 is a little bit bigger than 8/16. So hey, 9/16 is a little bit bigger than a half. 5/13 is a little bit less than a half, so 9/16 is bigger. Last problem. 3/8 compared to 9/24. Okay, well, I don't have a common numerator, I don't have a common denominator. They're not both one piece away from a whole. So now I can't compare to a landmark because both of these are smaller than a half. 9/12 is a half. I'm sorry. 12/24 is a half. And so 9/12 is smaller. 4/8 is a half. 3/8 is also smaller. So none of those things work. Okay, so I'm going to try to make a common denominator. And what I notice is that 8 is actually a multiple of, or 24 is actually a multiple of 8. So that makes this kind of easy for me. I can do 3/8, and let's make it into 24ths. So how I do that is I multiply by a version of 1, and the one that I'm going to use is 3/3. So 8 times 3 is 24. Perfect. 3 times 3 is 9. So look at that. I got 9/24 and 9/24. So I've got one more where they are equivalent. Take a look at your own paper. See if you got the same things. If you did, give yourself a huge smiley and then send me a message either in the class comments or on Hangout to tell me how you did. If you have any questions, same thing. Please send me a message either in Hangouts or on the class, on the assignment, and tell me how you did. Nice job, everybody.